Hello students, welcome to this lecture 1 Polynomials. So in this lecture, first of all, we'll discuss Introduction 1 Polynomials. Okay, so you have studied algebraic expressions and their addition, subtraction, multiplication and division in earlier classes. Okay, so you also have studied how to factorize some algebraic expressions, and you may recall the algebraic identities, okay, that you have studied in your previous classes. So in this class here we first of all introduce polynomials by recalling algebraic identities. Okay, so first algebraic identity is basically x plus y whole square. This is equal to x square plus 2xy plus y square. Okay, and the second identity is x minus y whole square. This is equal to x square minus 2xy plus y square. Okay, and the third identity is x square minus y square. This is equal to x plus y times x minus y. Okay, so we have known about these identities in our previous classes. So you have already studied about these algebraic identities. Okay, so now and their use in factorization. So in this chapter we shall start our study with a particular type of algebraic expression that called polynomial. Okay, so in this class we will study a particular algebraic expression that is called polynomial, and the terminology related to it. So we shall also study the remainder theorem and factor theorem and their use in factorization of polynomials. Okay, so that we have studied, that will study. Okay, so in addition to the above, here we shall also study some more algebraic identities and their use in factorization and in evaluating some given expressions. Okay, so the main motive of this chapter basically study a particular type of algebraic expression that is called polynomial, and the terminology related to it, and also study the remainder theorem and factor theorem, and then use the factorization of polynomials, use them in factorization of polynomials. Then we also study some more algebraic identities and their use in factorization and evaluating some given expression. Okay, so these are all our goal of this chapter. So first start polynomial in one variable. So what is polynomial in one variable? Okay, so student, you have already studied what is variable. Okay, so you know about variable. So if we have a expression like p of x is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a2 x square plus a1 x plus a naught. Okay, so if we have this algebraic expression, okay, so the polynomial p of x in one variable x is an algebraic expression in x of the form this. Okay, so p of x, this is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 a2 x square plus a1 x plus a naught. And here the variable is basically x, and the an minus 1 n dot 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 a2 a1 a2 a naught, they are actually constants. They are called constants, and x is called variable. Okay, so variable means which vary in expression that called variable. Okay, and which is in the value which are constant or not vary in an expression that is called constant. Okay, so a naught, a1, a2 dot dot an, they are called constants, and here an does not equal to 0, and the power of the variable x should be whole number. Okay, that case we can say this expression p of x is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a2 x square plus a1 x plus a naught. This algebraic expression is called a polynomial in one variable x. Okay, so now here a naught, a1, a2 dot dot an are respectively the coefficients of x naught, x1, x2 and dot 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 xn. Okay, so in our previous slide there we have studied a naught, a1, a2 dot 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 an. They are basically constants in expression. Okay, and here in this slide we call a naught, a1, a2 dot dot an. They are actually coefficients of x naught, x1, x2 and dot 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 xn respectively. Okay, and n, this is called the degree of the polynomial. So n is called degree of the polynomial. So each of an x to the power n, an minus 1 x to the power n minus 1 with an does not equal to 0 is called the term of the polynomial p of x. Okay, so if we have polynomial p of x, this is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a2 x square plus a1x plus a naught. Okay, so here this an x to the power n, an minus 1 x to the power n and dot 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 a2 x square, a1 x and a naught, these are all called term of the polynomial p of x. Okay, so for example, must be a whole number exponent, no limit one number of variables. Okay, so the power of the variable should be whole number. Okay, otherwise the expression will not call a polynomial in one variable x. Okay, so now here we'll discuss degree of polynomial in one variable. So degree of the polynomial in one variable is what? So what do you mean degree of a polynomial in one variable? So the degree of a polynomial refers to the highest exponent or power of the variable in the polynomial. Okay, so if we have a polynomial p of x is equal to an x to the power n plus an minus 1 x to the power n minus 1 and plus dot 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 plus a2 x square plus a1x plus a naught. Okay, so here a naught, a1, a2 dot 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 an are constants and they are actually coefficients of the variable coefficient of variable x to the power n, x to the power n minus 1 and dot 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 x and x naught. Okay, so here the degree of the polynomial basically refers to the highest exponent or power. Okay, so when if we have this when you have this expression here, when n does not equal to 0, then the highest power of this expression is basically n. Okay, so here the degree of this expression p of x is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a2 x square plus a1x plus a naught. Here the degree of this expression or degree of this polynomial is basically n, but here an should be not equal to 0. Okay, so the degree of a polynomial refers to the highest exponent or power of the variable in the polynomial. If a polynomial has no variables or no variable terms, okay, well constants terms, okay, so its degree is considered 0. Okay, so when you have a polynomial with no variable, that means when you have a polynomial that is the terms of that polynomial is always constant. Okay, so that case the degree of that polynomial is considered 0. Okay, so for example here we consider the polynomial 3x square plus 2x minus 1. So here in this expression this expression basically is a polynomial in one variable x. Okay, and here the highest power of the variable x is what? So here the highest power of the variable x is 2. Okay, so in this example here highest exponent of the variable is 2, therefore the degree of the polynomial is 2. Okay, so the degree of the polynomial is 2, or second degree polynomial. So now here we'll discuss types of polynomials. Okay, so polynomials can be categorized based on the number of terms they possess. Okay, here the breakdown of the different types. First type is monomial. So when a polynomial is called monomial, so a polynomial with only one term, that polynomial is called monomial. Okay, so monomial means mono means one. Okay, so monomial, that means a polynomial with only one term. Okay, that polynomial is called monomial. For example, you can take 2x, 7a square, and so on. So these examples are actually example of monomial. Here in this example 2x, we have only one term 2x. Okay, so here this polynomial is called monomial. And here 7a square, we have only one term of this polynomial. So this actually a polynomial with only one term. Okay, so this is also a monomial. And then next type is actually binomial. So a polynomial with two terms is called binomial. So what is binomial? So binomial means a polynomial with two terms. Binomial means what? So bi means two. Okay, so bi means two, and here binomial means a polynomial with two terms. So for example, you can take 5x plus 2. Okay, so in this polynomial 5x plus 2, here we have two terms. One is 5x and other is 2. Okay, so this polynomial 5x plus 2 is a binomial. Okay, this is a binomial. And the second example, 3y square minus 4. So here the terms are 3y square and minus 4 respectively. So here in this polynomial 3y square minus 4, here this polynomial has two terms. Okay, has two terms. So therefore this polynomial is a binomial. And then trinomial. What do you mean by trinomial? So tri means three. Okay, so a polynomial with three terms. A polynomial with three terms is called trinomial. So a polynomial with three terms is called trinomial. So for example, you can take 2x plus 5y minus 4. So here in this polynomial, we have three terms. Okay, one is 2x, second is 5y, and third is minus 4. So this is a trinomial. And then a cube plus b cube plus c. Here we have three terms. First term is a cube, second term is b square, and third term is c. So this is also an example of trinomial. And then we will classify polynomial based on degree. Okay, so classification of polynomial based on degree. So linear polynomial is what? So a polynomial of degree 1 is called a linear polynomial. Okay, so if we have a polynomial of degree 1 is called a linear polynomial. For example, x minus 12. Here the degree of this polynomial is 1. Okay, so this polynomial x minus 12 is a linear polynomial. So what do you mean by linear polynomial? So linear polynomial means a polynomial of degree 1. Okay, so if we have a polynomial of degree 1, then that polynomial is called a linear polynomial. Okay, and for example, x minus 12. And then quadratic polynomial. So what do you mean by quadratic polynomial? Quadratic polynomial. So a polynomial of degree 2 is called a quadratic polynomial. Okay, so if we have a polynomial of degree 2, then that polynomial is called a quadratic polynomial. Okay, students. And for example, you can take 2x square minus 3x plus 5. Okay, so 2x square minus 3x plus 5. This polynomial is basically the degree of this polynomial is basically 2. Okay, so this is a polynomial of degree 2. So therefore 2x square minus 3x 3x plus 5, this is a quadratic polynomial. Okay, and the third type based on degree is cubic polynomial. So a polynomial of degree 3 is called a cubic polynomial. Okay, for example, you can take this. So 4a cube minus 100a square plus a minus 6. So here you can see the degree of this polynomial is basically 3. Okay, so this polynomial for a cube minus 100a square plus a minus 6, this polynomial is basically degree 3. So this polynomial is a cubic polynomial. Okay, so we have studied here classification of polynomials based on terms. Okay, and based on terms there are 3 types of polynomial. One is monomial, second is binomial, and third is trinomial. Okay, and based on degrees there are some types of polynomials like linear polynomial, quadratic polynomial, and cubic polynomial. Okay, so now here if the variable in a polynomial is x, then we may denote the polynomial by p of x or q of x or rx, etc. So for example, we may write p of x is equal to 2x square plus 5x minus 3. Okay, so this is actually a polynomial of degree 2. So this is a quadratic polynomial. Okay, and in terms of the classification of in terms based on terms, here this is basically trinomial. Okay, and q of x is equal to x cube minus 1. So this is basically a cubic polynomial based on degree. Okay, since the degree of this polynomial q of x is 3. Okay, so q of x is basically a cubic polynomial. But based on terms, here we have 2 terms in this polynomial, so this is actually a binomial. And ry, this is equal to y cube plus y plus 1. So here here based on terms, this polynomial ry is basically trinomial. Okay, and based on degree, this is actually a cubic polynomial since we have ry with degree 3. And then this polynomial s of u, this is equal to 2 minus u square plus 6 into u to the power 5. So here the degree of this polynomial is 5. Okay, so this polynomial is of degree of 5. So a polynomial can have any number of terms, that is finite number terms. Okay, for instance, you have x to the power 150 plus x to the power 149 plus dot 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 x square plus x plus 1 is a polynomial with 151 terms. Okay, so we consider the polynomials 2x, 2, 5x cube minus 5x square, y, and u to the power 4. So do you see each of these polynomial has only one term? Okay, so polynomials having only one term are called monomials. Mono means 1. So these are all monomials. And now observe each of the following polynomials. P of x is equal to x plus 1 and q of x is equal to x square minus x. R of y is equal to y to the power 9 plus 1 and t of u is equal to u to the power 15 minus u square. So how many terms are there in each of these? Okay, so each of these polynomials has only 2 terms. Okay, so polynomials having only 2 terms are called binomials. Bi means 2. Okay, so these polynomials are basically binomials. Okay, so these are all binomials since in the each of these polynomials has only 2 terms. Okay, and then similarly polynomials having only 3 terms are called trinomials. Tri means 3. So some examples of trinomials are p of x equal to x plus x square plus 5. Okay, so in this polynomial we have 3 terms in this polynomial, so this is actually a trinomial. So here in this polynomial q of x equal to root 2 plus x minus x square. Here we have 3 terms in this polynomial, so this is also a trinomials. Okay, and in ru here we have also 3 terms, so this is also a trinomial. And in ty there we have 3 terms, also. Okay, so this is also a trinomial. So each of these examples, each of these polynomials basically are trinomials. Okay, so trinomials means what? Polynomials having only 3 terms are called trinomials. Okay, so now look at the polynomials. P of x is equal to 3x to the power 7 minus 4 times x to the power 6 plus x plus 9. Okay, so what is the term with the highest power of x? What is the term with the highest power of x? So it is basically 3x to the power 7. This term here we have highest power of x. Okay, so the exponent of x in this term is basically 7. Okay, so the exponent of x in this term is 7, and similarly in the polynomial q of y is equal to 5 times y to the power 6 minus 4 times y square minus 6. Here the term with the highest power of y is 5 into y to the power 6, and the exponent of y in this term is 6. So we call the highest power of the variable in a polynomial as the degree of the polynomial. So the degree of the polynomial 3x to the power 7 minus 4x to the power 6 plus x plus 9 is 7, and the degree of the polynomial 5y to the power 6 minus 4y to the power 2 minus 6 is 6. Okay, so the degree of a non-zero constant polynomial is 0. So note it down. The degree of a non-zero constant polynomial is always 0. Okay, and it is also note that the highest power of the variable in a polynomial is called degree of the polynomial. Okay, so now here we'll see example. So in first example, we have to find the degree of each of the polynomial given below. Okay, so here we have this polynomial. In first one, x to the power 5 minus x to the power 4 plus 3. Okay, so we have x to the power 5 minus x to the power 4 plus 3. So student, here what is the degree of this polynomial? So here the highest power term. So the term which involves the highest power of this polynomial, highest power of the variable is x to the power 5. Okay, so exponent of highest power term is basically 5. Okay, and the highest power of the polynomial is basically called the degree of the polynomial. So degree of this polynomial is basically 5. And in second one we have 2 minus y square minus y cube plus 2 times y to the power 8, and in third one we have 2. Okay, so let us see the answer. So the highest power of the variable in first polynomial is 5, so the degree of the polynomial is 5, and the highest power of the variable is 8 in second polynomial, so the degree of the polynomial is 8. Okay, and the third polynomial, that is actually constant term. Okay, constant term 2, so the only term is here 2, and which can be written as 2 times x to the power 0. Okay, so the exponent of x is basically 0, therefore the degree of the polynomial is 0. So degree of the polynomial is 0. And now let us now observe the polynomial p of x is equal to 4x plus 5, and q of y is equal to 2y, and rt is equal to t plus root 2. Okay, and su, this is equal to 3 minus u. So do you see anything common among all of them? Okay, so do you see anything common among all of them? So in first one we have p of x is equal to 4x plus 5. Second one we have 2y. Third one we have t plus root 2, and fourth one we have 3 minus u. Okay, so here each of these polynomials actually having degree 1. Okay, the degree of each of these polynomial is basically 1. So a polynomial of degree 1 is called what? So a polynomial of degree 1 is called a linear polynomial. Okay, so these one polynomials, so each of these polynomials basically are linear polynomial. So these are all actually a linear polynomial. So some more linear polynomials in one variables are 2x minus 1, root 2y plus 1, 2 minus u. Okay, and now try and find a linear polynomial in x with 3 terms. Okay, so now try and find a linear polynomial in x with 3 terms, and you would not be able to find a linear polynomial in x with 3 terms, because a linear polynomial in x can have at most 2 terms. Okay, so a linear polynomial in x variable can have at most 2 terms. So any linear polynomial in x will be of the form ax plus b. Okay, so any linear polynomial of the variable x in the variable x will be of the form always ax plus b, where a and b are constants and a does not equal to 0. Okay, why? because because here in this form we have 2 terms only, x and b, and we also see a linear polynomial in x can have at most 2 terms. Okay, so the general form of a linear polynomial is basically x plus b, where a and b are constants and a does not equal to 0. And similarly, ay plus b, this is also a linear polynomial in variable y. Okay, so now consider the polynomials 2x square plus 5 and 5x square plus 3x plus y, and x square plus 2 by 5x. Okay, so we consider these polynomials. So do you agree that they are all of degree 2? So here, do you agree that they are all of degree 2? So these one polynomials, each of polynomials basically, each of polynomials is a degree 2. Okay, so a polynomial of degree 2 is called basically a quadratic polynomial. So these are all some examples of the quadratic polynomial. So some examples of quadratic polynomial basically this. So here we can also give some more examples of a quadratic polynomial, that are 5 minus y square, 4y plus 5y square, and 6 minus y minus y square. Okay, so can you write a quadratic polynomial in one variable with 4 different terms? So the answer is, you will find that a quadratic polynomial in one variable will have at most 3 terms. Okay, so you cannot write a quadratic polynomial in one variable with 4 different terms. Okay, so a quadratic polynomial in one variable basically will have at most 3 terms. So if you list a few more quadratic polynomials, then you will find any quadratic polynomial in x is of the form basically ax square plus bx plus c, where a does not equal to 0 and a, b, c are constants. Okay, similarly, quadratic polynomial in y variable will be of the form a y square plus by plus c, provided a does not equal to 0 and a, b, and c are constants. Okay, so the general form of any quadratic polynomial in x variable is of the form ax square plus bx plus c, where a does not equal to 0 and a, b, c are constants. Okay, so now we call a polynomial of degree 3 a cubic polynomial. So some examples of a cubic polynomial in x variable are 4x cube, 2x cube plus 1, 5x cube plus x square, 6x cube minus x, 6 minus x cube, and 2x cube plus 4x square plus 6x plus 7. Okay, so how many terms do you think a cubic polynomial in one variable can have? Okay, so how many terms do you think a cubic polynomial in one variable can have? So it can have at most 4 terms. Okay, so a cubic polynomial cannot have more than 4 terms. So the cubic polynomial can have at most 4 terms. So this may be written in the form ax cube plus bx square plus cx plus d. So this may be written in the form ax cube plus bx square plus cx plus d, where a does not equal to 0 and a, b, c, and d are constants. Okay, so this is the general form of a quadratic, general form of the cubic polynomial. Okay, so now Now you have seen that a polynomial of degree 1, degree 2, and or degree 3 looks like. So can you write down a polynomial in one variable of degree n for any natural number n? So or if a polynomial in one variable x of degree n is an expression of the form an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a1x plus a naught, where a naught, a1, a2 dot dot an are constants and a n does not equal to 0. Okay, so in particular, when a naught, a1, a2 dot dot an are 0, then we get a 0 polynomial, which is denoted by 0. And what is the degree of the 0 polynomial? The degree of the 0 polynomial is not defined. So degree of the 0 polynomial is not defined. So this all about this lecture. So I stop here this lecture. Thank you very much to all of you.